Hello people! So far we know that when an object moves, it changes its position, which means that it travels some distance. In this session, we will learn in detail about the change in position and the distance traveled by an object. Let's start with an example. Suppose you and your friend ran to the ice cream parlor after school. You took this path which is 800 meters long and your friend took a shortcut which is 500 meters long. We define distance as the total length covered along a path. So the distance traveled by you is 800 meters and by your friend is 500 meters. In this case, we saw that different paths can be used to travel between the same initial and final position. So the distance we travel can also be different for the same initial and final position. And this distance depends on the length of the path we choose to travel. But the interesting thing here is that even though you and your friend travel different distances, both of you are at the same location now, which is 200 meters away from your school. And we define this quantity as displacement. Displacement is equal to the length of the straight line joining the initial and final position. To be more specific, we also include direction in displacement. In this case, your and your friend's displacement is 200 meters north. Here 200 meters is the magnitude of displacement and north is the direction of displacement. So your displacement tells you that your final position is at 200 meters in the north direction from your initial position. Unlike distance, your displacement doesn't depend on the path you choose. Your distance traveled from the school to the ice cream parlor may be 800 meters, 500 meters or 1 kilometers. But the displacement will always be 200 meters north. So between any two locations, the distance traveled depends on the path, but the displacement depends only on the initial and final position. Great! Now you are familiar with both distance and displacement. So next time when you go somewhere, try to compare the distance you travel with your magnitude of displacement. We have seen earlier that representing a position on a straight line makes our life simple. We can easily represent two directions with a positive and negative sign. Let's see how we calculate distance and displacement in a straight line motion. Suppose a car which is initially at position 3 meters goes to minus 4 meters. So the distance traveled by the car is 3 meters plus 4 meters, which is equal to 7 meters. But what about the displacement? We know that displacement only depends on the initial and final position. So we calculate displacement by subtracting initial position from final position. In this case, displacement is equal to the final position minus initial position, that is minus 4 minus 3, which is equal to minus 7. So the 7 represents magnitude of displacement and the minus sign represents the direction of displacement, which is the left in this case. In straight line motion, the negative value of displacement shows that the final position is on the left of the initial position, while the positive value of displacement shows that the final position is on the right of the initial position. An interesting observation is that the distance and the magnitude of displacement are equal in this case. This is because the path of motion is a straight line joining the initial and final position. But what if the car turns and comes back to point C at position minus 1? The path that the car traveled from point A to C is this. So the total distance traveled becomes 7 meters plus 3 meters, which is equal to 10 meters. What will be the displacement now? The final position is C and the initial position is A. So, the displacement is final position minus initial position, that is -1 minus 3, which is equal to -4. In this case, the magnitude of displacement is less than the distance. What if the car comes back to point A? The total distance travelled is 7 meters plus 7 meters, which is equal to 14 meters. Any idea what will happen to the displacement? Yes, it is 0 now. Since the initial and final positions are the same, the total displacement is 0. So whenever a body moves, it may have 0 or non-zero displacement, but it will always have non-zero distance. In these cases, we saw that the magnitude of displacement is always less than or equal to distance. Let's look at another situation. Suppose an athlete is running around a 400 meters long track. What can we say about the distance travelled and the displacement after each round? After the first round, his distance is 400 meters, while the displacement is 0, since the initial and final position is the same. After each round, the total distance will keep increasing, while the total displacement will be 0. So, if you ever go running, tell your friends how much distance you covered, not your displacement. That's all about distance and displacement. Now let's have a quick recap. We learned that distance is the total length covered along a path, while displacement is the change in position of an object. We saw that distance depends on the path, while displacement is independent of the path and depends only on the initial and final position. We saw that distance is always positive, while displacement can be both positive and negative. We also saw that distance only has magnitude, while displacement has both magnitude and direction. And finally, we've seen that distance is always greater than or equal to displacement, while displacement is always less than or equal to distance.